All right, when you get back to your desk, sorry, I'm going to podcast this. Open it up to page 139 and 140. Now, we are going to do the life cycle of the star. It's going to take the entire spread, 139 to 140, like what I have created here. Yeah, I'm going to move it over to 141, because I want the entire spread for this. 139, 140, we're going to do the spread of the life cycle. Okay, I'm moving it to 141. Because I want the entire spread. And this is section 2, so I want to make sure I stay in order. So across the top, to start off with, I'll keep it 2 pages. Journey of a Star. Okay, for the 4th time, I am moving the essential questions to page 141 so that I can have the entire spread of the Journey of a Star on these 2 pages and to keep my sections in order. So the essential questions will be moved to 141 if you run over 138, 37. Journey of a Star. Okay, so at the top for the title, Journey of a Star, off to the right-hand side of page 140, we're going to put a little diagram of the temperature difference between stars from cold to hot. What is the color of a cold star? Red, so you can either put red. And what is the color of a hot star? Blue. So it actually goes across the color spectrum in order from red to blue. So next would be, once it starts cooling, orange, and then yellow, and then green. Or you can write it in. Either way, I don't care. Red, orange, yellow, green, blue. Across. Yep, you can do what I did. In colors or in words, it doesn't matter. Alright, just make sure you're paying attention and not doing anything else because I want to get through the entire spread today for the rest of the class period. If I write in all caps, I want you to write in all caps. I'm going to put all the different stages. Their names are in all caps, but their descriptions are not. Okay, so again, if I write it in all caps, I want you to write it in all caps. Okay, I'm going back to a single page. Okay, down the right-hand side of, or excuse me, the left-hand side of your page, you have a red line. About halfway down on the left side of the red line, I want you to put, it all starts here. It all starts here. What is here? Where does it all start? The life of a star. What is the first stage? Anybody know? Yeah, what's it called? Nope.
What?
That was just, that was an example of what it would look like. And they call it the pillars of creation because of what it looks like. That's not what the stage is called. I'm glad you remember that. That'd be the next stage. Nebula. Yep, it is called the nebula. So, again, we're halfway down the page, and I'm going to put in all caps, nebula. Now, I'm going to draw a picture of a nebula. I'm going to grab blue. At this stage, it really doesn't matter what color. I'm just going to put some dots. I'm going to put some arrows that are pointing in. Now, why am I having those arrows point in?
Gravity.
Gravity, yep. Gravity is pulling all the gas and dust particles in. So my description, hey Sean, I'd go to the next page. because it's gonna look like this. Okay, so you should be on this page. All right. So the description is, it is a cloud of gas and dust. Cloud of gas and dust. It is made up of 3% helium and 97%, what's the next element that it's made out of? Hydrogen, very good. I will send this to you when I get done, in case you missed something. Cloud of gas and dust, 3% helium, 97% hydrogen. Okay, after this stage, this splits into two paths. Now, the path of a star depends on one thing. What one thing determines the life of a star? Mass. Very good. So underneath the title, I just want you to make a bullet. The star's life depends on its mass. The star's life depends on its mass. Okay, this next stage, we can call it a protostar, we can call it a main sequence star, either or. I'm going to make an arrow. I'm choosing orange for my arrow. I don't care what color yours is. Choosing orange though. Create a arrow to an object where all of the gas and dust particles have been pulled together. It's called.
Is that just like yellow circle?
Yeah, just a yellow floating circle. It's called the main sequence. Most of our stars are in as a main sequence star because the majority of their lifespan they spend in this on this path. A main sequence star is when the star finally begins to shine. So underneath, the star shines because nuclear reactions occur. And these nuclear reactions produce light and heat. Star shines, nuclear reactions produce light and heat. Okay, so if it is a large mass star, I'm going to create an arrow that's going to go up. Okay, this arrow that's going to go up is going to represent our path that our large mass stars are going to take. And off of that arrow, I'm going to have part of it going down as well, which is going to represent the path that our low mass stars take. So the top is going to be our large mass. The bottom is going to be our small mass. If it is a large mass star, it's going to be hotter. So what color is it going to be to start off with, you think? Blue. So a large mass star is going to be called a blue star. Blue star. And a small mass star, we don't want it so cold that it's going to completely not put off any light or heat. So what color do you think a small mass star would be? Yellow. Very good. Yellow. Close.
Never mind.
So small mass star would be a yellow star. Is our sun a large mass star or a small mass star? It is a small mass star. Our sun is a small mass star. Now at the bottom left, why do we get so much heat and so much light from the sun, yet it's a small star?
It's
Because we're so close to it. Yep, so I want you to make a note. The sun is the closest star to Earth. So if there was another star that was much bigger in mass and was the same distance, obviously it would be really hot here on Earth. Sun is the closest star to the Earth. Okay, so if it's a large mass star, the next stage that it's going to go to, it's in this stage for a really, really long time. It's going to start cooling down. And when it starts to cool down, it turns to the color red. So those are our cold stars. And it's a large mass star, so I'm going to make a big red circle. And it is called a red supergiant. A red supergiant. Now, a small mass star, similar, however, it's not a supergiant, it's just a red giant. So a small mass star, the next stage is a red giant. Okay, now in both of these stages, basically the same thing is happening. The only difference is their mass. So I'm just going to put some little arrows kind of coming down. I'm going to put the description in the middle. At this stage, the star is expanding and glowing red because the surface, you just need to sit down, there's nothing to go. Surface cooling. You'll just have to make up, I'm obviously podcasting, so you can make that stuff up, and I'll send you the link. Alright, so again, after it determines its mass, if it's a large mass, it goes blue star. Once it starts to die off, it becomes a red supergiant, which expands and glows red because the surface of it is cooling. Same thing with the red giant, it's just not super because it's smaller. Alright, I'm going to take mine to page 140. So to page 140. The next stage of a large mass star, it has become so large and cooled so fast that an explosion has occurred. What is this giant explosion called? Yep. Say it louder. Say it louder. A supernova. Yep. This is going to be, yeah, it's going to be, well, right off of your arrow from red supergiant. Okay. So did you create an arrow from the red supergiant? Just start on page 140. Yeah. And make this arrow. And then I'm going to create a star that kind of looks like it's exploding somewhat. And again, this is called a supernova. A supernova, which is a giant explosion. And in this giant explosion, what is happening is the outer layers of the core are blowing off. So the outer layers are blown off. Now, because so much of it is blown off, and it's such a big explosion, and it's blown off so far, that when these gas and dust particles blow off, they can actually be recycled back into a new star. So I'm going to take an arrow from my supernova all the way back to my nebula. And on there somewhere, I'm just going to put recycled. So part of that explosion that blows off can get recycled back into a nebula and kind of start all over. If it is not a large mass star, it is a small mass star. It doesn't have an explosion. However, it's doing something very similar. It's taking its star and just kind of, I'm going to use the term puffing off the gas and the dust particles. And this is called a planetary nebula. Now, the reason why they call it that is because it kind of looks like a planet with its own little atmosphere and its own little star system, kind of like what Earth has. And again, I'm using the term puff because it's not blown, exploded off, it puffs off the outer layer.
Is that orange or?
Well, it's part of the red supergiant, and then I just put my little puffs off as orange. You don't have to. No, I suggest possibly doing it. When I write in capitals, you write capitals. When I don't. Puffs off outer layer. All right. After the supernova, not much is left of the star, but something is left, and it can take two paths depending on what is left. So I'm going to put a path up here. I'm going to put a path down here. The first path, depending on if there's part of the core left, it's called a neutron star. Now, a neutron star, just like it sounds, is made out of neutrons. And if you remember from the chemistry unit, the neutron is what gives an element its mass. So this star is very, very dense. At the end of the video, it talked about if two neutron stars were to collide, it would create a massive explosion that would kill almost everything in the universe made of neutrons. Okay, and the other path that it could take if there really is nothing left except for the power of gravity, a black hole.
What's that yellow thing?
Light. So a black hole, the gravity is so strong that it traps everything, including light. So if light were to get in it, light cannot get out. So it traps everything, even light. And that's the end of a star, a large mass star. Now down to the small mass star. The next stage on the small mass star is called a white dwarf. A white dwarf, I'm going to put in green, I haven't used that color yet, would obviously be white. That leads to us. White dwarf. A white dwarf is a small, hot star. That's why I put it in green. There was a purpose. It's the shrunken remains of a star. The nuclear energy has been used up, or is being used up. And then the last stage is called a black dwarf. It no longer has the energy to even glow anymore.
I thought that was a brown one.
Nope. black dwarf can no longer produce light or heat. Now, they say that the time needed to reach this stage is longer or older than the age of the universe. So there are no black dwarfs that exist. However, they predict this is what would happen. Now, Serena said this is a brown dwarf. It is not a brown dwarf. However, let's make a note. A brown dwarf is a failed star. And a brown dwarf could come off of the white dwarf, but they said there are only, 5 that exist, or less than 100 that exist, so it's very rare for something to become a brown dwarf. And if it does, they say it looks like a planet. Alright, the very last thing I want you to add, if you have a space in the middle where you can add it, you can. If you have space at the bottom of that page, you can add it. I have mine in the middle, so I'm going to write it in the middle. There are more than this many stars.
Holy crap. What's that number called?
2 times 10 to the, that's what I would say.
Isn't that like 1 billion or something? Trillion?
2 times 10 to the 23rd stars. So a lot of them. Okay, so this is the life of a star. Now, on Monday, we're going to discuss different galaxies. They touched a little bit about it on the video. Now, again, you guys know that we live in the Milky Way galaxy. The Milky Way galaxy is a spiral galaxy. It is only a very small portion of the universe. So just remember, we have, in our solar system, we have our sun and then all of our planets outside. Outside of our solar system is only part of the Milky Way galaxy. So let's say the Milky Way galaxy extends all the way down like that. Okay, so beyond our solar system, there is more of our Milky Way galaxy. Now, beyond the Milky Way galaxy, there's other galaxies. So beyond this green portion, there is more to the universe. It's so expansive that they don't know the end of it, because they can't get there in a timely manner. So, all right, if you are done with your colored pencils, please return them. I didn't check anybody's.
They all go up there.